Lap 4. Objective is to drive straight 100 centimeters and then drive back 100 centimeters. Same as lap 2, but we are allowed to use encoders to adjust on the fly. Now, here's the latest iteration of my code. First, it sets up the serial monitor, then the loop, waits for the button, waits 2 seconds, calls for my function to drive forward, waits 2 seconds, then calls for it to drive backwards. Forward is a value of 1, and backward is a value of -1. This allows me to use the same function to drive both forward and backwards. First, what it does is it resets the encoder counts. Then it calculates the pulses required using the function given in the example code. And then it sets the initial motor speeds. The write speed is a constant value of, in my case, 80. And then D, direction, is multiplied there. That is the value that is either 1 or -1 based on going forward or backward. Then speed left average is the initial speed of the left. Whenever the robot's driving at the right is driving at 80, this is found to be around like 76 whenever it evens out. So start with 76 to avoid it curving on startup. Then sets those speeds at the initial, and then the loop, where it drives while it continues the loop while one of them has not reached the objective. First, it reads the encoders, and then calculates the adjustment required and sets it to the value. First, it calculates the error of the left encoder count compared to the right, and then it uses this equation where it calculates error off of the constant of the starting speed, rather than what I had before, which was before it was going off of a fluctuating number. However, now it is set to a constant. And then the S is like a sensitivity percentage to affect how much it does it. I set it originally to 15%, but then I raised it to 50, and now it's just straight up 100%, which means that it's no longer used, but it's there if needed. I raised it up there because I found that it would raise whenever it would start, it would turn and then go straight in the wrong direction. But then as I raised the number, then it would start off straighter and straighter. Then there is a safety function which I implemented during testing. Basically, it wouldn't allow it to go over the max or below the minimum speed, which I had set to like 200 and 0. But since this works, up here, I went ahead and commented this out. And then notice this sets speed left. It doesn't set the speed of the motor. It sets the value of this. Then down here, it can be overridden that if it had reached the target, it is overridden to be equal to 0. Same with the right motor. And then it sets the motor speed. Then it repeats the loop, and then whenever the loop is broken, which is when both of these would have stopped because both of them reached the destination, then it makes sure, just in case, that it has indeed stopped both of the motors, and then it jumps out of the function, allowing for it to be called again. So now let's go ahead and run the function. About somewhere like there. Waits 2 seconds, drives forward to 100 centimeters, and then it drives backwards after waiting 2 seconds. Now if we go ahead and plug it in, we can see the serial monitor's outputs. So now when we run it, there are the values given. As it drives straight forward 100 centimeters, it stops, and then it continues because it's running the function again. And then here you can see, such as right here, the encoder counts is at 956 and 965 with the speed of 74 and 80. The error is 9, applies 9 correction to the constant, as you recall from here. However, you can see here the error in correction is consistent the entire time until about here. So that 74 is its sweet spot. So there we go.